Exercise 7.11. Question number 1. Integration 0 to pi by 2 cos square x dx. Here we are going to use property integration 0 to a fx dx equal to 0 to a f a minus x dx. Suppose question is equal to I. 0 to pi by 2 cos square x dx. Now we use this property. So it will become I equal to, suppose this is equation number 1. 0 to pi by 2 cos square pi by 2 minus x dx, which will become 0 to pi by 2, and cos pi by 2 minus x will become sin x. So it will give sin square x dx. Suppose this is equation number 2. So if we add 1 and 2, we will get 2i equals integration 0 to pi by 2 cos square x plus sin square x dx, which will be equal to 0 to pi by 2 cos square x plus sin square x will become 1. So it will be dx. So 2i equal to 0 to pi by 2 dx. And if we integrate it, we will get dx will become x, limits 0 to pi by 2, which will give 2i equals pi by 2, implies I equal to pi by 4. Now let's go to question number 2. Question number 2 is 0 to pi by 2 root sin x dx divided by root sin x plus root cos x. Again, we are going to use same property. 0 to a fx dx gives 0 to a f a minus x dx. Suppose the question is equal to I. So I equal to 0 to pi by 2 root sin x dx divided by root sin x plus root cos x. Suppose this is equation number 1, and we write further I equal to 0 to pi by 2. We use the property. So sin pi by 2 minus x, pi by 2 minus x dx divided by root sin pi by 2 minus x plus root cos pi by 2 minus x. Sin pi by 2 minus x will give cos x. Similarly, cos pi by 2 minus x will give sin x. So this will become 0 to pi by 2. It will be root cos x dx divided by root cos x plus root sin x. Equation number 2. If you observe carefully, the denominator of equation number 1 and equation number 2 are same. So we can add directly. So it will become 2i will be equal to 0 to pi by 2 root sin x plus root cos x dx divided by root sin x plus root cos x, which will give 2i equal to integration 0 to pi by 2 dx, which will become x, limits 0 to pi by 2, or 2i equal to pi by 2, which gives I equal to pi by 4. Now let's go to question number 3. Question number 3 says 0 to pi by 2 sine power 3 by 2x dx divided by cos 3 by 2x dx plus sine 3 by 2x dx. Again, we are going to use same property. 0 to a fx dx is equal to 0 to a integration f a minus x dx. So suppose the question equal to I. So 0 to pi by 2 sine 3 by 2x dx divided by cos 3 by 2x plus sine 3 by 2x. Suppose this is equation number 1. Now, by using property, again we write I equal to 0 to pi by 2, and this will become sine 3 by 2 pi by 2 minus x dx divided by cos 3 by 2 pi by 2 minus x plus sine 3 by 2 pi by 2 minus x. So sine pi by 2 minus x will give cos theta, and cos pi by 2 minus x will give sin x. So it will become 0 to pi by 2 cos 3 by 2 x dx divided by sine 3 by 2 x plus cos 3 by 2 x. This is equation number 2. Now, denominators are both equation 1 and 2 are equal, so we can add directly. So it will become 2i equal to 0 to pi by 2 sine 3 by 2x plus cos 3 by 2x divided by sine 3 by 2x plus cos 3 by 2x dx, which is equal to 2i equals integration 0 to pi by 2 dx, which will give x limits 0 to pi by 2, or 2i equal to pi by 2, which implies I equal to pi by 4. Let's go to question number 4. Question number 4 says integration 0 to pi by 2 cos power 5x dx divided by sine power 5x plus cos power 5x. So again, we assume this as I. So I equal to 0 to pi by 2 cos power 5x dx divided by sine power 5x plus cos power 5x. This is equation number 1. Now we use the property 0 to a fx dx gives 0 to a f a minus x dx. So it will become I equals 0 to pi by 2 cos power 5 pi by 2 minus x dx divided by sine power 5 pi by 2 minus x plus cos power 5 pi by 2 minus x. And cos pi by 2 minus x will give sin x, and sine pi by 2 minus x will give cos x. So we will get 0 to pi by 2 sine power 5 x dx divided by cos power 5 x plus sine power 5x. Suppose this is equation number 2. Now, if you observe carefully, the denominators of both the equations are same, so we can add. So it will become 2i equals 0 to pi by 2 cos power 5x plus sine power 5x dx divided by cos power 5x plus sine power 5x. Now we will get 2i equals 0 to pi by 2 dx, which will give x and limits 0 to pi by 2. So 2I equals pi by 2. Thereby, we will get I equals pi by 4. Now, let's go to question number 5. Integration minus 5 to plus 5 modulus x plus 2 dx. Here, we have to check the sign of function x plus 2 in different intervals. So for this purpose, we write x plus 2 equal to 0. So we get x equal to minus 2. So we have to write it on number line so that thing may become clear. The lower limit is minus 5. Then we have got the value of x as minus 2, and then upper limit is 5. So here in this interval from minus 5 to minus 2, function will be negative, and from minus 2 to 5, function will be positive. So we break this integral in two parts, minus 5 to minus 2, and we write minus sign x plus 2 dx, and then from minus 2 to 5, we write positive x plus 2 dx. So we integrate it. So if we integrate, so keeping minus sign outside, this will become x squared by 2 plus 2x, limits minus 2 plus 2x, limits minus 2 to 5. Now you have to put the limit. This is work for you. I'm not solving it. Question number 6. Question number 6 says integration 2 to 8 modulus x minus 5 dx. Here again, the same process is to be adopted. Put the term inside the modulus equal to 0. X minus 5 equal to 0. From here we get x equal to 5. Now we draw the number line and we locate the limits. Given limit is 2. Then we have got the value 5 that lies in between, and then upper limit is 8. So in first interval, the function will be negative, and in second interval, function will be positive. So we write it as 2 to 5, and we write minus sign outside, x minus 5 dx, and then from 5 to 8, function will be positive, x minus 5 dx. Now we evaluate. So it will become minus of x squared by 2 minus 5x, limits 2 to 5, plus this will become x squared minus 5x, limits 5 to 8. You know how to put the limit. So next part is left for you. Thank you for watching.